Hi everyone, welcome to my YouTube channel CTF Electrons, and in this video we are going to talk about polynomials. Okay, polynomial interpolation. Okay, polynomial interpolation. Okay, hope that's okay. Yeah. Alright, example. Now, when we say polynomial interpolation, what do we mean? Polynomial interpolation is a common method used to estimate intermediate values between precise data points. Okay, so when we want to estimate value between data points, let's say we have something here, we have another thing here, 1 point here, 1 point here. We want to estimate values between these data points. That is the idea of interpolation. But this interpolation now is done with polynomials. So polynomial interpolation. Okay. So the general formula for an n minus 1 order polynomial can be written as f of x a1 a2x a3 x squared a4 x cubed and so on. So for n data points, there is one and only one polynomial for order n minus 1 that passes through all points. For example, there is only one straight line, that's a first order polynomial, that connects 2 points. Makes sense? Look at this. There is only one straight line that connects these 2 points, okay, as seen in figure A. Similarly, one parabola connects set of 3 points. 3 points, one parabola connects them, okay, and connects a set of 3 points as seen in figure B. Also a third order cubic connecting 4 points as seen in figure C, which is this. Okay, so it's just like it's one less. The data points, the order connecting the data point is one less than the data points. Are we seeing it? So if we have n data points, the order will be what? N minus 1. Okay? So how do we determine polynomial coefficients? So a straightforward way of computing the coefficients of polynomial is based on the fact that n data points are required to determine n coefficients. Very simple. If we want to know the coefficients of n data points, okay, if you want to know the coefficients of polynomial, you need to know the number of data points. You need to know the number of data points to know the number of coefficients you get. So example, suppose that we want to determine the coefficients of the parabola. We want to find the coefficient of this that passes through density values from the table below. So this is the density values. Okay, we want to determine the coefficient for this. Now a simple solution: x1, x2, x3, that's the temperature, x1, x2, x3. The density values are the f of x, f of x1, f of x2, f of x3. As simple as that. Okay, now recall that we said we gave this expression. Where is it? This expression, that the general form, yeah, f of x is this. Okay, now since we have 3, f of x1, 2, 3, since we have 3, we are going to have what? 3 different expressions, 1, 2 and 3. So one of them we are going to have what? F of x1, that will be what? 0.612. Then P1 300 squared, P2 just 300, P3 no x value. Okay, so the first one we are dealing with what? X1. So this first equation we did what? F of x1 and x1. So f of x1, look at it here, x1 squared, x1, then no x1, or x1 is power 0. Okay, then in next we go to what? f of x2, look at it, then x2 squared, x2 not squared, then no x2. Okay, or we can say x2 is power 1, x2 is power 0. F of x3, look at it here, then this x3 500 squared, 500 raised power 1, 500 raised power 0. Okay, so from the first equation we just reverse this thing, take this one to this other side, meaning have it here, and then this raised power 2 is 90,000 p1, 300 p2, and p3, just like that. Same to this, crossover. Okay, and square this guy, get this. Okay, and this crossover comes this way, squared, get this, this. Okay, now if you look at this, it looks just like this. It looks just like this. Can you see that? It looks just like this. Okay, yeah, it looks just like that. So you can use either naive Gauss elimination or Gauss-Jordan method to resolve it. Okay, so yeah, that will be end for this video. So in the next video we'll talk about Newton's interpolating polynomial. Okay, so thanks for watching and bye for now.